All right, I think we're going to go ahead and get started. Welcome, everybody. On behalf of the Genetic Counseling Program and the Department of Human Genetics, we are really excited to welcome you to the 14th Annual Diane Baker Alumni Lecture. Today, we'll be honoring Diane Kohler, who is a 2016 graduate of the dual degree program in Genetic Counseling and Public Health. Before we talk about Diane Kohler, I wanted to take a moment to recognize Diane Baker, for whom this award is named. Diane Baker's career at Michigan spanned over 25 years, and during this time, she founded the Genetic Counseling Program and served as our first program director. In addition to her role as an educator, Diane provided genetic counseling in pediatric genetics, administered the state of Michigan's newborn screening program, coordinated outreach clinics in northern Michigan, and also provided outreach to teachers and students. Diane Baker's impact extended beyond the University of Michigan and the state of Michigan, as she served in leadership positions in virtually all of the national genetic societies. She co-edited the first textbook in genetic counseling and was importantly involved in the 2008 passage of the Genetic Information Non-Discrimination Act. Although Diane is unable to join us today, I know that many of our human genetics faculty saw her at last week's ASHG meeting, and perhaps she's still recovering from a fun night on the dance floor. And you can see, I don't know if you can see, in the back there is Francis and Tony playing the live music for the dance floor. So Diane, we know you're joining us virtually, and we're sorry you can't be here in person. So when we initiated this award 14 years ago, our goal was to identify members of our alumni community whose professional activities honored Diane Baker's legacy. This year, we are thrilled to honor our other Diane, Diane Kohler. Diane completed her undergrad degree at Carnegie Mellon, where she majored in both biology and psychology. Here at U of M, she earned her MS in genetic counseling and her MPH in health behavior and health education. During her time here as a student, Diane was a really self-sufficient student who quietly excelled in really everything that she did, including in the classroom, clinic, and research endeavors. As a student, Diane was awarded a Jane Engelberg Memorial Fellowship Student Award from the National Society of Genetic Counselors, and was subsequently awarded the JEMF Student Manuscript Award for her work in 2018 for her graduate thesis. Diane then contributed to the work of another University of Michigan Genetic Counseling Program alumni, Tessa Marzullo, where they continued their work related to the impact of personal genomics, the PGen study. Since graduating, Diane has worked as a clinical and research genetic counselor with cancer genetics and prevention at the Dana-Farber Cancer Institute in Boston. She currently serves as a lead genetic counselor for several research studies, and we'll be hearing a lot more about that research today. Diane is also a passionate advocate for healthcare equity for members of the transgender and gender diverse communities. To that end, she has been actively involved in educating providers, organizations, and graduate students on how to make clinical and research practices more equitable to gender diverse communities. We've been really fortunate to have Diane contribute to some of our own students' efforts in this very area, including in the development of educational modules that have been widely used by genetic counseling students across the country, as well as currently practicing genetic counselors. Diane's ongoing involvement in clinical care, research activities, and education characterize her role as a role model and an ideal candidate for this award, and I couldn't be more excited to welcome Diane up to the stage. Congratulations. Thank you. All right, so now the pressure's on. Share screen. Okay.
Thank you. Thank you so much. Thank you for that introduction. And I'm really honored to be here and really happy to be back. It's been a great morning meeting with the students. So today I'm going to be talking about some of my research areas. My talk is titled Utilizing Genetic Counselors in Research from a Study of Germline EGFR Variants to a Pilot of Cancer Panel Testing in Rwanda. I have no conflicts of interest to disclose. So while the focus of my talk today is not on my advocacy work, largely because of Amplify and how a lot of the GCs here and the students here have access to Amplify already, I did want to mention today is the first day of Trans Awareness Week. So it's a good time for everybody to take some time to learn and reflect. There's a lot of great resources on transequality.org. Also a great week to talk to your legislators. So there are currently 6 anti-trans laws active in the state of Michigan. So on tracktranslagislation.com, you can connect with your local legislators and encourage them to vote no on these bills. And it's also a great time to support local trans organizations. So these are 3 Michigan-based trans organizations: Stand with Trans, Transgender Michigan, and Transcend the Binary. Oh, okay. Oh. All right. Thank you. And 1 week from today is also Transgender Day of Remembrance. So this is a day to honor the lives of those lost each year to anti-trans violence, which is still very prevalent in the world today. The Human Rights Campaign on their website, they keep an annual list of fatal violence against the trans and non-binary community. So I encourage everybody to take some time next Monday to learn about some of those lives we've lost this year. So November is also Lung Cancer Awareness Month, and this brings me into the first research study that I'm going to be talking about today. So I think, like many GCs, lung cancer was not always at the forefront of what I was thinking about. We did not receive a whole lot of training in hereditary lung cancer or lung cancer in general during grad school. I think most of us are trained when somebody says there's a lung cancer in a family member, you just kind of ask, did they smoke, and move on and don't really pay too much more attention to it. So definitely a space that I had a lot of learning to do when I entered this research study. So to give a little background on lung cancer in general, it is still the leading cause of cancer death worldwide. In the last year in the US, about 1 in every 20 cancer-related deaths was due to lung cancer. Up to 25% of people diagnosed with lung cancer have no history of smoking cigarettes, and this number is only increasing because smoking rates are going down. And even when you separate lung cancer in people who smoke compared to lung cancer in people who've never smoked, lung cancer in never smokers is on its own the 7th most common cause of cancer death worldwide. We've also seen that there's a number of studies showing a familial component to lung cancer. So if you have a first-degree relative with lung cancer, your risk is increased by up to 2.7 times. And even 4th-degree relatives of a non-smoker with lung cancer have an increased risk of disease. So we assume with 4th-degree relatives, there's not a huge amount of shared environmental factors. So it seems like strong evidence of a familial component. Somatic genotyping has been really common for a long time in lung cancers. So genes such as EGFR, ALK, and ROS1 are routinely somatically genotyped in the CARA advanced non-small cell lung cancer to help determine the sensitivity to targeted therapies. We've seen that somatic EGFR mutations are really common in non-small cell lung cancers, and they often indicate a favorable response to a line of treatments called tyrosine kinase inhibitors, or TKIs. So if you hear someone referring to a lung cancer as an EGFR-driven lung cancer, they're usually talking about a somatic mutation and not a germline one. And we have seen that after a time on treatment with these tyrosine kinase inhibitors, many people will develop an acquired resistance mutation in EGFR called T790M, which makes those treatments less effective. So most of the time, these T790M mutations are induced by the treatment and are not present prior to the treatment. This is the pedigree of the first described germline EGFR T790M mutation. So this was reported in 2005. And it was largely based on the striking family history of lung cancer that was seen. So you can see the proband on here had multiple close relatives with lung cancer or lung nodules. And so it made the researchers suspicious that this may be germline, which turned out to be true. Since that first report, there were several other studies that then attempted to identify germline EGFR T790M carriers based on clinical features such as family history, but they were having really limited success. So people were having a really hard time identifying germline carriers based on family history alone. Jeff Oxnard in 2012 found that tumor genotyping was a more effective means of screening for these germline carriers. So his hypothesis was that if T790M is a resistance mutation, it really shouldn't be appearing prior to treatment. So he hypothesized that these germline mutations might be the cause of people who had somatic T790M mutations at baseline or treatment naive mutations. And he did find that 5 out of 10 unrelated individuals who had baseline somatic T790M mutations were found to be germline. So about half of those who have treatment naive T790M were found to be germline carriers. And only 2 of them had a family history of lung cancer, so they wouldn't have been picked up if we were just using family history as a screening tool. So this brings us to the Inherit EGFR study, or the Investigating Hereditary Risk from T790M. So this was the very first study that I participated in my time at Dana-Farber. And the goals of this were to determine the prevalence of germline EGFR mutations in individuals with somatic T790M in their lung cancer and in the relatives of germline carriers. We are also hoping to assess the natural history of lung cancers in germline EGFR carriers and estimate the prevalence of lung nodules in these carriers. There were 3 cohorts that we included in this study. So cohort 1 was our primary means of referrals, and these are people who had tumor genotyping with a suspicious EGFR mutation at baseline. We were able to consent in person or remotely. This study launched in 2012, so I was not involved in it at the start, but the remote consenting was pretty novel at that time. And it was because these were believed to be very rare that the remote consenting was thought to be pretty necessary to capture the population. You can see that counseling was provided throughout. So this was a very genetic counseling heavy protocol. So we provided counseling pre-test about germline testing to everybody who enrolled. If they decided to move forward with the germline testing, they provided either a saliva or blood sample for targeted single site EGFR testing. Once their results were available, they received a letter in the mail informing them they had results, and it had their genetic counselor's phone number if they wished to learn their results. So we did have some participants who participated, had their testing, but chose not to learn their EGFR status. But those who did received more post-test counseling about their results, and then received additional counseling if they were positive about inviting relatives to participate. To get cascade testing, we basically would ask our probands how many relatives they were interested in sharing recruiting information with, and we would send them packets for all of those relatives. It was on them to share it with their relatives, and then the relatives would come in through cohort 2, which was the relatives of germline carriers. Cohort 3 was for people who had previously tested positive for germline EGFR mutations, but this ended up being pretty small because most commercial testing labs didn't have EGFR available at the time this study was going. And also for those who tested positive, we collected CT images and followed them for 2 years. So we ended up getting 141 participants from 62 apparently unrelated kindreds enrolled between 2012 and 2018. These participants represented 33 US states, as well as Australia and Brazil. And we ended up having 131 participants complete germline EGFR testing, so very few decline testing after the pre-test counseling session. And we identified 76 participants from 39 kindreds who tested positive for a germline EGFR pathogenic variant, either T790M or another variant, R776H. And we ultimately found that germline T790M mutations were found in 52% of the participants who had T790M in their lung cancer at diagnosis. So that 50% chance of it being germline, if it's seen at baseline, seemed to hold up in this bigger cohort of patients. So we analyzed the pedigrees of the 39 families that tested positive, and through looking at them, we were able to identify 91 confirmed or obligate germline EGFR pathogenic variant carriers. We found that 45% of them were unaffected with lung cancer, with a median age of 47, and 55% of them were affected with lung cancer, with a median age at diagnosis of 56, and the range was 28 to 83, so quite a big age range at diagnosis. and 60% were never smokers. So we still had a large population that had a smoking history, but the majority were never smokers. And ultimately, 52% of the germline EGFR pathogenic variant carriers were diagnosed with lung cancer by age 60. This is the best penetrance estimate we can give from our data, but there is some ascertainment bias because all of our probands were affected with lung cancer. So we don't know if this risk would hold up in folks like incidentally found to have EGFR on panel testing. Another thing we noted was that 35% of probands had a first-degree relative with lung cancer and 27% had more than one first-degree relative affected, but that still means that there were a lot of folks who had no family history of lung cancer and once again would not have been picked up by that method of screening. So this is one of our family histories that we collected. So the proband on here is a 70-year-old male with a diagnosis of lung cancer at 65, and he was a smoker at the time of his lung cancer diagnosis. You can see that his mother and his brother had both died from never smokers' lung cancers. So for him, learning his germline status actually helped relieve a lot of guilt that he was feeling surrounding his lung cancer diagnosis. So he had really been blaming himself because of his smoking history. So the germline mutation kind of helped clarify what happened with his family members who had never smoked and helped lift some of the blame that he was experiencing. And this also, we were able to test his nephew, so we were able to confirm that his brother was an obligate carrier of the mutation. This was another family that shows just how different it can look even within one family. So the proband on here was a 46-year-old diagnosed with lung cancer with more of a social smoking background. His brother had died at 21 of lung cancer, had never smoked cigarettes, and his father had tested positive, was 82, had a significant smoking history, and had never diagnosed lung cancer. So it can look very different even within one family. We don't know if the younger brother actually had the EGFR mutation because no testing was done on him. So there are a lot of unique counseling challenges working with this population. I think lung cancer among cancer diagnoses is pretty unique in the stigma, blame, and shame that's associated with it because it is so closely tied to cigarette smoking. I think this graphic kind of sums it up nicely. Someone says you have breast cancer, you say, I'm so sorry. Someone says you have prostate cancer, you say, that's awful. Someone says I have lung cancer, you say, did you smoke? And I think as genetic counselors, we do kind of feed into that with how we ask about lung cancer on a family history. So we do kind of have a role in reinforcing some of the stigma that goes along with it. It's also a really poor prognosis disease. We have very limited data on the risks of carrying a germline EGFR mutation, so we counsel about a lot of uncertainty. There's no referral or testing guidelines for EGFR. There's no evidence-based screening guidelines. Insurance coverage can be really challenging to obtain. And there's a lot of limited support for previvors. So it's still a pretty small community of EGFR carriers that we've identified, and there's not a whole lot of specific support available for them. So we did have some challenges with screening our unaffected EGFR carriers. Since we were enrolling remotely, there were some geographic challenges for participants to access CT screening. It was kind of on them to try to find a local provider who would order a CT scan for them, and then it would be reimbursed by the study, but that's easier said than done. And so we only were able to screen 15 of our unaffected pathogenic variant carriers with low-dose CT scans. We did find 60% of them had lung nodules, including a 28-year-old who had over 10 lung nodules. Most of those who had nodules, they were bilateral, multifocal. It was almost described as a polyposis of the lungs, essentially. And one additional participant did go on to develop lung cancer during our 2-year follow-up period. It's still really unclear what the ideal screening interval is, especially if somebody does not have any nodules identified. We don't know how frequently we should be repeating their scans. And it's also unclear what age we should be starting the screening. So we've seen cancers and nodules in the 20s. So we think the 20s is a reasonable time to start, but we still need more data to know that for sure. We also noticed this kind of unexpected finding of the southeastern US having a disproportionate clustering of our EGFR positives. So we thought that there might be some type of founder effect going on within the southeastern US. And this led us to do a haplotype analysis. So we did genome-wide haplotyping of 46 of our participants with germline T790M. And we found that 41 of them shared this haplotype that surrounded T790M, indicates a shared common ancestor about 11 generations or 250 years ago for those who had the shared haplotype. So ultimately, who should consider genetic counseling or testing? There's still really unclear guidelines on this, but for those who have a somatic T790M variant, especially if it's at baseline prior to any treatment, that still seems to be the best way to screen for these germline carriers. There have been a couple other suspicious somatic variants identified, like R776H, and some people with a gene mutation in ERBB2, so we look for those as well. Family history of multiple individuals with lung cancers or nodules in non-smokers could be an indication, but we still don't have really clear guidelines for what family history qualifies. Young lung cancer patients has been a big question mark for us. We don't have enough data yet to really show if earlier age at onset is predictive of carrying a germline mutation, but it is something we want to look into more in the future. And like I said, we have no established testing criteria, so insurance coverage can be challenging to obtain. Now that EGFR is on a lot of commercial panels, we actually have more success often testing under something else like Lynch syndrome or BRCA if there's some other family history versus getting coverage for EGFR specifically. So the INHERIT study has been closed for a number of years now, so I am very excited that we now have some new openings, new studies opening up, because I do feel like we left some of our carriers in a little bit of a limbo when the study ended. So we have two new studies. The young lung cancer study is open now, and the new INHERIT study is opening hopefully by the end of the year. We'll be doing basically a similar model, but we'll be offering more testing this time. So we're going to do gene panel testing rather than single site testing. We're also going to collect samples for research, whole genome and transcriptome sequencing and DNA banking, and we'll be offering screening with low dose CT. So we're very excited to be able to get our families kind of loop back into a study. So there were a lot of lessons learned from my work on this project. This was a study I really dove into very early in my career, basically as soon as I started working. Didn't really know what I was doing. I lovingly say that I was voluntold to work on this study because nobody else wanted it. But I really fell in love with it. I felt like the GCs on the team were really valued. We were really the heart of the study because we were the ones working the most closely with the participants, providing education and support. We were also really successful at recruitment and cascade testing. For some of these families, we recruited up to 14 members of the same family to the study. We also were really the ones keeping this research patient-centered and kind of keeping the patients at the center of everything. So there were a lot of opportunities from working on this project as well. I was able to gain a lot of confidence counseling with a lot of uncertainty because we have such limited data. I was able to support whole families through a rare disease diagnosis. I was able to start advocating with the labs for inclusion of EGFR on commercial panels and to gain expertise in a very rare disease. So this is a picture from NSGC in 2017. We got 3 of our participants to come to Columbus with us and talk about their experiences so we could learn from them and present to other GCs. So I really caught the research bug with that first study, and when it ended, I was eager to dive into other projects. So the next study that I actually volunteered for this time was called PROACTIVE, or the Profile and Cancer Gene Testing for Individual Evaluation Study. This is a Dana-Farber-wide study. There's a whole lot of different goals to it, but basically we were trying to collect an expanded cohort of patients, so participants we don't typically see for germline cancer genetics, to study the implementation of genetic testing with a pretest video education rather than traditional pretest counseling. We are trying to comprise a library of annotated germline specimens on which we have research, whole genome, and RNA data, and essentially enable data sharing of that research library. So there are 2 different arms to this study. So there's a mandatory research arm through which we collect blood samples for research, whole genome sequencing, whole transcriptome sequencing, and DNA banking. These results are de-identified, put into the research bank, and they are not returned to participants. And then there's the commercial testing arm, which is an optional opt-in arm. And through this, we collect an additional blood or saliva sample for cancer gene panel testing. We do a large panel, it's between 133 and 156 genes. The pretest genetics education is provided by a 7-minute video. Negative or VUS results are just sent through a letter, and positive results are called out by a GC. These are some snippets of our video that we use, so it's just under 7 minutes. We chose to go with an animated video so that we could more easily translate it into other languages, and we could edit it more easily than a talking head. And this was developed with kind of the whole team of genetic counselors developing the script, trying to get through everything we would typically cover for informed consent and cover in a pretest counseling session into as short a video as we could. So for the cohorts for this study, we basically did a roadshow to all of the different disease centers across Dana-Farber, and each disease center was eligible to create their own cohort and responsible for consenting their own patients. So we handle the results, but the disease centers handle their own consenting and recruiting. They were encouraged to select a cohort of patients that would not traditionally be referred for genetic counseling and testing, but they could ultimately choose whatever group they were interested in. So these are just some examples of the groups that were selected. So our GU department decided to go with 2 cohorts. They're collecting renal cell carcinoma and bladder cancer. GYN collected endometrial cancers with normal IHC, so specifically the non-Lynch associated endometrial cancers, and GI collected cholangiocarcinomas. So a couple years ago at NSGC, we presented some of the preliminary results from the commercial testing arm. So within the first 2 years that the study was open, we enrolled 840 participants, and we ended up getting germline gene panel testing results for 607 individuals. Ultimately, 94% of those who watched the video did consent to testing. So we had really high genetic testing uptake from our pretest video. 21% of participants were found to have a positive germline result, which was a little surprising to us because these were supposed to be low-risk populations. That being said, about half of those positive results were purely recessive risks or carrier risks, or were low risk and not something that would actually alter medical management. So we did have like CFTR on the panel, so a lot of the positives are CFTR carriers. So that's an overinflated number. We focus more on the 11% that had clinically actionable germline results. So still maybe a little higher than we thought for a low risk population, but I think that's a more accurate representation of the positives. So we found 68 pathogenic and likely pathogenic variants, and 65% of patients were clinically actionable. And only 14% of the pathogenic variants identified were associated with high penetrance. So still most of the positives we were finding were more in the moderate penetrance range. And also one thing that was interesting was only 11% of the pathogenic variants were concordant with the cancer history. So most of these were more incidental findings, at least based on the participant's personal history of cancer. This is a lot on this slide, but basically this just shows the breakdown of the pathogenic variants that were picked up. So the most common variants we found were SPINK1, CFTR, MUT-YH, CHEK2. So nothing super surprising. We're probably just picking up general population frequency of a lot of these common variants. So our current enrollment as of last week, we have commercial testing results for 1,096 participants. The study is still ongoing. We've identified at least one pathogenic germline variant in 23% of our cohorts. So that number stayed pretty consistent. We're also very excited that we've completed whole genome sequences now for 1,832 participants. So I highlighted our top 5 cohorts that we've collected on here. So we have 331 with lung cancer, and within that, 208 were diagnosed under age 46. So we kind of have a separate young lung cancer cohort. We have 307 with pediatric cancers, including 92 specifically with pediatric thyroid cancer, 191 with endometrial cancer with normal IHC, 179 with multiple myeloma, and 153 with sarcoma. So we have some good groups here. We're excited to dive more into the data from the whole genomes. So our next steps for this study are to ultimately reach a recruitment goal of at least 200 participants per cohort, because that's going to be the most useful from a whole genome analysis perspective. We also want to describe the commercial testing results and the impact they have on medical management by cohort. We want to do genome and transcriptome annotation to build out our research library. Right now, we just have a whole lot of raw data, so it's not the most useful in its current state. And we also ultimately want to promote data sharing and analysis of this research library data. So a lot of lessons learned from this study as well. The GCs were really valuable for the development of our pretest video education. We do all of the results delivery. So my main role on this study is calling out all of the positives that come through from the commercial testing. And it's also been a great opportunity for provider education. So we're working with a lot of providers who don't typically send a whole lot of patients for genetics and need a little bit more help interpreting genetic testing results than the providers we're used to working with. So it's been a really great opportunity there. GCs in the study also have the opportunity to gain confidence educating other providers, working with larger data sets, working with patients from different disease centers than what we typically see, delivering a lot of unexpected positive results to participants we don't have any prior relationship with. And we've even taken the opportunity to apply this pretest video clinically within our clinic. So this was not the first study that we did that involved a pretest video education. So we essentially modified the video so that it could be used in clinic. And now the majority of our cancer patients at Dana-Farber receive the video rather than traditional pretest counseling. So it's had real clinical applications. So the last study that I'm going to be talking about today is our landscape analysis and implementation of cancer germline genetic testing in Rwanda. So something very different from the prior studies. This is supported by an R01, and this set of slides is adapted from a presentation that was jointly created by myself, Tim Rebeck, and Dio Fidelu. And our goals here are to develop and evaluate a set of essential cancer genetic protocols for cancer genetic testing, counseling, and management in low resource settings, and ultimately undertake a pilot evaluation of genetic testing and counseling in breast and prostate cancer patients in Rwanda. This is the core research team, the key personnel from this study. So it is a joint collaboration between people at Dana-Farber, the Rwanda Biomedical Center, and various hospitals within Rwanda. So the majority of the team is local to Rwanda. There's three main pilot project activities. So there's a patient interview and a provider survey, both of which are assessing the knowledge and attitudes towards hereditary cancer testing. For the purpose of this talk, I'm going to be focusing more on the third activity, the genetic counseling and testing pilot, because this is where I've had the most involvement. And our goal here is to conduct panel-based germline genetic testing on a pilot of 400 patients with breast and prostate cancers in Rwanda. So for this pilot, the inclusion criteria, all the participants have to have a current or prior diagnosis of breast or prostate cancer and be considered at risk for a deleterious germline mutation. We roughly used NCCN criteria for who qualified as at risk for a mutation. These participants were recruited via direct referral from a clinician and review of the EMR. These genetic counseling clinics are happening in person at the Rwanda Cancer Center every Saturday, and basically 20 participants are invited every Saturday to come into these clinics. We are very grateful for the team there who's willing to donate their Saturdays for this study and get all these patients seen. When the patients arrive, they are consented and their eligibility is assessed by a research assistant. And then the genetic counseling is provided by one of three study physicians. So they don't have any genetic counselors in Rwanda. So we worked with the providers there about who would be best to train. So we have 2 oncologists and 1 geneticist on the study. The geneticist we are very lucky to have because she does have experience with providing genetic counseling, but not in a cancer setting. So she was usually working in pediatrics, and we still had to do some more cancer specific training for her. And then ultimately, if they consent to testing, a saliva sample is collected by a nurse. So the genetic testing is performed at Invitae via their 84 gene multi-cancer panel. For those of you who work with Invitae, you might recognize the box of Invitae saliva kits. So that was us teaching them on how to do saliva collection. The results are reviewed by a study GC, so I have access to their Invitae portal, can review the results as they come in. And then for the positives, I offer any support the ordering provider needs for how to disclose those results to the patient, what the next steps should look like. The results are delivered to the patients by their physician. This is mostly happening in person, so they are invited back to clinic to receive their results. Family members are also eligible for free cascade testing at Invitae for people who test positive. So there was a lot of training needed to help support this clinic. So we first did a short course on cancer clinical genetics in Africa. We had initially intended for this to be an in-person course, but COVID had other plans. So we punted and made it a remote course. I made it available online. So this included 6 recorded lectures on various genetic counseling and testing topics, and including case presentations and role plays. And then this was followed by live Q&A sessions with the speakers. We really just designed this for the core research team and for the local providers who would be referring patients to the protocol. But we decided since we were doing it online, we would just make it free and open to anybody who was interested. And we ended up having over 1,000 participants from 59 countries, including most African countries. So that was really surprising to us and something that highlighted how much of an interest in this education there is and how much of a need there is. These lectures are still available online at africanoncogenetics.org. Once we were able to safely travel to Rwanda, we also did a lot of local training and recruitment. So when we were there, we hosted a one-day in-person workshop in Kigali with members of the core study team and local oncology providers. We went over topics like current research advances in cancer prevention, genetic counseling for cancer patients, the impact of cancer genetics on cancer management, and an introduction to the protocol. We also spent a lot of time traveling to local hospitals, meeting with their leadership to discuss the protocol, who should be referred, and how to refer patients over. We also met with leadership from the Rwanda Biomedical Center and the National Lab to discuss data management. We did more training with the core study team, meaning the folks who were staffing the clinics every Saturday. So this was the physicians, nurses, and RAs who were going to be the direct contacts with the participants. This was largely role plays. So we went through role plays of medical history collection, family history collection, patient education, and informed consent for testing, as well as saliva kit collection and packaging. One of the big things we were focusing on with these role plays was language, because we know that not all of the terminology we use translates easily into Kinyarwanda, the native language, and just the way we talk about a lot of genetics concepts didn't necessarily translate culturally. So we spent a lot of time trying to figure out how to make this make the most sense in their context while still providing appropriate consenting and counseling. So the pilot has been progressing really well. The local team has done an amazing job with recruitment. So the recruitment, consenting, and pre-test counseling has all been completed between April 2022 and April 2023. So they completed it within 1 year. We have reached the goal of 400 participants, and we have almost an even split between breast and prostate cancer, which is what we were aiming for. The testing has been completed for the majority of participants. We're currently working on completing the results disclosures because we are often needing to get patients back into clinic, which is sometimes a challenge. Repeating testing for failed samples and offering cascade testing. So there were a lot of challenges working on this study, just a lot of logistics things that we, fortunately don't have to deal with a lot in a higher resource setting, but just shipping kits and getting biological specimens through customs ended up being a big challenge. We ended up needing to batch the samples, and we would basically wait until there were 100 samples and ship them all at once. And this may have led to a higher rate of sample failures because some samples were sitting for a long time before they were able to be shipped. Like I said, not all of the language we use translates easily to Kinyarwanda. And prevention and medical management for those who test positive is available, but it's more limited. So another challenge we're working with now is what is reasonable medical management for those who have tested positive. So things like an MRI once a year is not really feasible in their context. So we're trying to come up with something that is feasible there. We've also found that cascade testing has been a challenge. So there's been really low uptake of cascade testing among family members. So it's definitely something that we need to look into more and see what those barriers are. So our next steps and future directions for this project, we're completing the results disclosures and any cascade testing that we can. We're going to analyze and publish the results from the genetic counseling and testing pilot, the patient interviews, and the provider survey. We also want to follow up with the patients about their counseling and testing experience and the impact that it had on them. We do want to work with the National Lab on capacity building to perform genetic testing in-house. So that has always been a goal of this project. We don't like that we have to send the samples out currently. And they do have a national lab with an NGS platform. So we are going to work with them on capacity building to ultimately move this in-house. We also want to formalize more genetic counseling training for the providers and make sure there's something sustainable to continue to educate new providers in genetic counseling. We want to facilitate the implementation of a sustainable genetic counseling and testing protocol and improve medical management for mutation carriers into the health system. So they do have a national healthcare system. So we need to kind of work with them on incorporating genetic testing and management as a covered service. Ultimately, we want to then expand this into other African settings. So once again, lessons learned, the GCs on this team were playing a very different role compared to the other studies, namely because there was no direct patient interaction. It was purely with providers. So we were really valued for our clinical genetics experience and expertise and our provider education and support. And it gave the GCs opportunities to think critically about the adaptation of clinical genetic services into more of a low resource setting. Learn a lot about capacity building and sustainability, and also defining your own role on a large interdisciplinary international team. When I joined this project, the protocol wasn't actually written yet. So it's kind of on me to think, what is my unique value here as a GC? What do I add to this team of people? So just some closing thoughts. I think GCs are really well suited to serve a variety of roles in research settings. And I think many of our clinical GC skills are really highly applicable to research settings, such as our education of patients and providers, interpretation and communication of complicated information, counseling and psychosocial support of participants. I think we have a lot of really unique skills to bring to the table. I didn't talk about this too much in the talk, but advocating for paid GC time on clinical genetics research studies is really important. If I did not have dedicated research time, there's no way I could be doing all of this and maintaining a full clinic load. So I am very grateful for management at Dana-Farber for really supporting research time for genetic counselors. Research also gives you an opportunity to collaborate with providers and patient populations you might not otherwise work with and help develop specialized expertise that you can bring to clinic. So I think being a clinician makes me a better researcher, and being a researcher makes me a better clinician. And I really love doing both. So I have tons of people to acknowledge, of course, the Inherit, Proactive, and Rwanda pilot teams, especially the genetic counselors that I've collaborated with on all of these projects. The whole Dana-Farber team, especially Jill Stopfer and Anu Chittenden, who are really the advocates for me and really help me get the dedicated research time that I need, and help open up these opportunities to me. I'm also very grateful for the GCP, especially the Diane Baker Committee for selecting me, the class of 2015 and 2016, and of course, all the faculty and staff. I feel like my education here really set me up well to jump right into this very early in my career, and I felt very well prepared for my training here. So I'm very grateful for the education I received. Thank you so much for your time.
I think we have time for some questions. And for those that are joining virtually, if you want to put any questions into the chat, that would be great. And I guess I'll start with a question. I'm curious, when you think about your training in health behavior and health education, how you think about the conversations that you have with your patients related to smoking and lung cancer.
I've thought a lot about that since working with the lung cancer population, because I still, when I take a family history of someone who has lung cancer, I still ask if they smoked. It's a reasonable question to ask, but I think how I talk about smoking has changed. I think I talk more about environmental risk factors as a whole rather than just focusing on cigarette smoking, to take some of the blame off of it, because a lot of exposures you can't control. But it's still, for people who do smoke, that public health brain is still like, I know this is still a risk factor. So I do think it's a challenge to walk that line of not adding to the stigma of a disease while still advocating for good public health. But I think it's a challenge. Yeah. Oh.
Thank you so much. This was amazing. So I have a question based on your first two studies and the high success rate of cascade tasting, and then comparing to the last one and like the low uptake of it. What do you think were some of the barriers that you didn't see in the first two, or like what are the things that you're planning to do based on the first two, like maybe increase the uptake for the third one? Thank you.
That's a great question. So I think it is still a big mystery with the Rwanda pilot as to what the barriers are for the low uptake. Our sense is that a lot of it is limited management. Because I think for participants based in the US, we can say, okay, here's the plan. If you test positive, we're going to get you a CT scan, we're going to get you a breast MRI, we're going to get these things for you. And we can't necessarily offer that in Rwanda's context just because there's so much less screening facilities available. So like we can still offer like surgical risk reduction, but we can't offer as much screening, for instance. So I think that is a major player. I also think there's just less knowledge and education about hereditary cancer risk in Rwanda compared to the US. It's not something that's really talked about. And so I think there's just seems to be less interest among the family members. But I do think it's something we absolutely need. We weren't expecting such low rates of cascade testing. So it is something we definitely need to think about more clearly and define better. Yeah.
Thank you. I want to ask the question about the R01. I assume you had no input into the submission of that. Was there anything, do you know, mentioning genetic counseling in the R01?
So genetic counseling was mentioned, but I wasn't a major player in the application for that. So it was the genetic counseling for this population was mentioned in it though, but I didn't have a huge role in the development of it.
Next time.
Yeah, next time.
Thanks, Diane, for a great talk. Maybe you could talk a little bit more. You mentioned some differences between Rwanda and the U.S. in important areas. Were there any kind of cultural differences in attitudes and beliefs regarding genetic testing you could elaborate on? I'm particularly interested in concerns about like genetic discrimination and
Yes.
things like that.
Mm-hmm. Yeah, so stigma was brought up as something we had to think a little bit differently about from a cultural perspective, particularly with our young breast cancer patients. So we were testing a number of people like in their 20s with breast cancer who already were kind of deemed less eligible for marriage because they'd already like lost a breast to breast cancer. And so there were a lot of concerns that doing genetic testing and finding a mutation would further stigmatize them and make them less desirable from a marriage perspective, which is very important to their social success moving forward. So it was a very different kind of cultural context around the stigma that we had to work around. Yeah. Mm-hmm. Yes. Yeah, absolutely. So there was a lot of back and forth about panel selection, especially because we were choosing to send to an outside lab, and Rwanda's preference was to keep things in-house. But we thought we could probably get their in-house lab up to doing like BRCA 1 and 2 testing, but not complete comprehensive panel testing. Our thought was that this is probably a one-time shot to get testing for these participants, and we felt that we wanted them to have what's the current standard of care in the US. We didn't want to just bring something to a low resource setting and then give them something less than what we're offering in the US in a high resource setting. So that was ultimately what it came down to, was just providing what we consider the current standard of care. We also weren't really sure what the mutation landscape was going to look like if we would expect BRCA 1 and 2 to be the biggest hitters, or if maybe other genes were going to be more prevalent in that population because it has been so understudied. So that was also part of the logic behind it. But we're planning to set up more of a knowledge exchange between Invitae and their national lab to help them work together to get their national lab up to the standards of doing panel testing.
Thank you. Thank you so much for this talk. It was really interesting. I'm just wondering, so you mentioned how the providers take out their Saturdays to see patients. Do you think that moving forward to access patients who are in maybe more rural places, do you think virtual visits could be the way forward in Rwanda specifically?
In Rwanda, I think it would be a challenge because there isn't reliable internet or even phone access. So we talked about potentially doing that, and most people have access to a telephone, so telephone counseling might be something feasible. But also within their cultural context, they're very used to meeting with their providers face to face. That's just how they prefer to receive care, it seems like. Because we also struggled with this with results delivery because we thought only the positives would have to come back, but they were finding that the VUS carriers were really struggling with getting those results over the phone. And so we elected to start bringing back people with VUSs as well for in-person results disclosure. So even though it was sometimes challenging for them to access, we were only at one site, so some people had to travel quite far to get into the clinic, it did seem like in-person was preferred. Yeah.
Great talk, Diana. And I'm taking a question from the chat. So Bev has joined us and wants to let you know it was a great talk. And she asks how you tested the videos that you used, either in development or post-development.
So the first study at Dana-Farber that we used a video was separate from the proactive study, and it was more of a talking head video, but there was a study called ProGen. It was a multi-site, multi-institute study, and it was a randomized control trial comparing the video education to traditional pretest counseling. So that was kind of our first pilot of using a pretest video. We found no difference in genetic testing uptake, in genetics knowledge, or in family communication. So based on the data from that study, we felt like it was an acceptable model. Granted, that was only patients with prostate cancer, so it was a limited group of patients that were tested. So for the development of the proactive video, we worked off the script from ProGen, had all of the genetic counselors on the team kind of review it, make changes, and we did a video satisfaction survey afterwards for the first subset of like 200 participants on the study, and it performed really well. So from that time, we just didn't do any further video satisfaction survey. We felt like it was working well. So it is something though we are looking, since we are adapting this into clinic, there are other studies now specifically looking at how this works in lower literacy populations, because we do want to make sure if we're using this as our standard that people with varying levels of health literacy are accessing the information appropriately. So